This is a supplement for assignment 2 of week 3 on color relativity. I would strongly urge all of you not to underestimate this assignment. It is a template assignment. Those typically are fairly simple. This is typically one of the hardest assignments most students have difficulty with. They struggle with it a lot because they underestimate it. I don't feel it's that hard. It's been around for many years. It goes with the Albers book, which I've mentioned to some of you. In the previous version of this course, this is all we did in week 3, but now it's condensed into just a single assignment. So I want to take a moment and go over the assignment with you. So you'll have a color here, and the goal of the first part of this assignment is to make the color look like two different colors. You want to change the appearance. So this is working with the illusion. You'll want to change the appearance of the hue, the value, and saturation for the most dramatic change. Let me stress that again. You want to change the appearance of the hue, value, and saturation for the most dramatic change. And I'm going to touch upon that later on. I wanted to just go over the assignment briefly in the beginning. For the second part of this assignment, so let's go ahead and scroll down here, you're going to have two different colors and you want to make them appear as one. Now what's important about these two different colors is that they need to be significantly different. For that, they should be at least 15 degrees difference in hue. They should not exceed 60 degrees difference in hue. It's going to be very hard to make them appear closer. Typically 30 to 45 degrees is sufficient. 30 degrees usually works out well for everybody, but at least 15 degrees difference in hues. They should be clearly different in saturation. Now we've talked about saturation. It is not just this S value. It is the S and B values together. So how can you identify saturation? So if you had a color, let's say it's just red, and it had S and B values of 54 and 50, and then you had one of 75 and 66, this would be clearly higher in saturation. That for anybody that has questions or is a little uncomfortable, having both the S and B values higher than the other, that would be a clear indicator that it's higher in saturation. We can go into it more detail in class for those of you that are interested, but for the simplest explanation, if both S and B values are higher, it is higher in saturation. Value. Remember, switch to grayscale. I want to see at least a 5% difference in value at a minimum. Preferably at least 10%, but at a minimum 5% in value. And you're going to want to, and then we'll use the theory that we're going to talk about here, and that's covered in the lecture, to create an illusion where these two will look similar. So moving on to the theory, and again, if you have questions about this, let me know, because this is going to be essential for the assignment. So moving on to the theory, the two easiest parts of this theory are the value. So obviously in this situation, and each part of this is only dealing with one part. So the bottom section here is only dealing with hue. This is only dealing with saturation. This is only dealing with value. Don't look at this example and assume it's dealing with all the portions at once. It's only dealing with them. I've broken it down into individual aspects because it's easier to think of them that way. So let's go ahead and zoom in over here to value. So obviously this right center is lighter in value. Obviously we can see here that this left center is darker in value. We can take measurements and see that. We're seeing that minimum 5% difference. So what happens based on that theory? When you have a relatively lighter background, it will make a darker center appear darker in value. When you have a relatively darker background, you will make a darker center appear lighter in value. So these two, while this is relatively darker, we can measure, see they're both 43, it will make, because this is darker, it makes it appear lighter. Because this background is lighter relative to this center, it makes the center appear darker. And now you have a situation where the values, their appearances change. Some may even think this starts to appear darker than this one. It's part of the illusion. My evaluation of this assignment will be based on the application of the theory, not on the subjective experience of the illusion. So what happens in this case is you've used a lighter background with the lighter center. That would be correct. A darker background with a darker center, that would be correct. So the application of the theory is correct. Now this, for the people that are experiencing this as being darker now than this, that's fine, but it's intended to overemphasize this illusion. Some of you may not be experiencing this. Some of you may see this as still being lighter, and that's okay too. What we're focusing on here is application of the theory. And I want to stress that as well. You should be able to factually use your values from the color window here, something we've been focusing on in week 2, to be able to state this out in facts, why the theory was used correctly in this assignment. This is an illusion we're dealing with, but we're going to approach it with facts. Saturation. Remember, we talked about those S and B values, having clear indication of which one's higher, which one's lower. This is an S value of 80%, a B value of 90%. This is an S value of 70%, a B value of 80%. This is clearly higher, clearly lower on the right. The background here, clearly less saturated. Based on the theory, what we've learned in the lecture, this less saturated background will make this relatively higher saturated center appear relatively higher in saturation. This relatively higher saturated background will make this relatively less saturated center appear lower in saturation. Since this was higher and this was lower, and this background's making this appear lower, this one's making this appear higher, this would close that visual gap. And so in saturation, they're moving towards each other. So if that's not clear, let me know. We'll talk about it some more. But that's the goal, is to close that gap visually and in theory. The subjective experience, you can tweak it as much as you like, work towards it, but the theory application needs to be correct in the end. So in hue, there's 2 main illusions occurring. You're subtracting the hue, you're also adding the complement. So let me go ahead and zoom out here, and I'm going to zoom back in because I want to be able to get this whole section here for you to see. So again, we have this, it's basically a red-orange at hue 20. We should be familiar with the color wheel at this point because we covered it in week 2. We have a yellow-orange here with hue 40. So in subtracting, this can be helpful at looking at the RGB values if you're unfamiliar. So you go back to your color wheel, we bring it up here. So a red-orange, if we bring it up in RGB, is made up of part red light, part green light. If we're subtracting red light, we're only subtracting red aspects. What does that do to something that's made of red and green light? That allows the green to become more dominant. What happens in that situation? It's moving towards yellow. So if you have something here at orange and you're subtracting from here, it's pushing it this way. It's going to push it towards yellow. Okay? So that should be somewhat clear. Same thing happens if it's orange and you're subtracting the yellow aspect. You have to keep in mind that yellow is made from red and green, so essentially you're subtracting green aspects and you're going to push it towards red. You can think of it any way that you like, but just remember, if you're subtracting one side, you're pushing it in the other direction. It's all that you really need to kind of keep in mind. For complements, you're adding the complements. So keep in mind, in a situation like this, and you have an orange, let's go back to HSB so you can see this a little bit easier. It's usually easier for early color theory students to identify colors by hue. So you have hue 20. You have blue background here. You're adding the complement. Think about what the complement of blue is. It's yellow. You're adding complement yellow to this orange. What would that do? You know, you can think about this in paint if it's easier. What would happen to an orange if you added yellow paint? It would become more of a yellow orange. But just keep in mind that you're working in the additive system here. That's going to also be a key to remember. You don't want to confuse the traditional system here. That can also be an issue. So another reason to keep this, let me move it out of your way here, additive system color wheel handy so you have your application correct. So in this case, the cyan, you're adding red. You know, don't think of this as a blue and think that you're adding yellow. You need to realize with a cyan, you're adding red. So with the yellow-orange, you're going to move it towards orange, and that's going to be important. So then at the bottom row here, let me move this up out of your way. You can mix them, subtract and add. So with the red-orange, you subtract red aspects, move it towards a yellow-orange, and then with the yellow-orange, you can add red back from the cyan complement, and so that would move it towards a red-orange, and it would start to move them towards each other based on hue. If you have questions about that, let me know. But those are the two main ways that you're going to mix hues. You can do it through complements, by adding the complements, or you can subtract hues. Typically, one or the other is going to be dominant based on proximity. We'll talk about this a little bit more. I'm going to post a number of files to help you out here with this. But don't underestimate this assignment. I cannot stress that enough. And it's really going to test your skills on identifying hues, identifying complements, identifying saturation, identifying value, and manipulating all three at once. And we did this to some extent last week in week 2 for depth, because you're looking at those aspects when you're dealing with depth. We did this to some degree during week 1. We were dealing with these aspects of color. So now we're really testing to see how well you understand those aspects and can manipulate all three at once. So if you just kind of keep track of the three at once, it shouldn't be that hard as long as you don't underestimate it. And if you have any questions, let me know. Thanks.